Alright class, one more video I wanted to go over. So this is kind of an introduction to polar coordinates in 6.4. You don't have these notes, but you can still follow along here. Maybe take some paper out and jot down a few notes. Now if we're talking about a point in the XY plane, like what we've got here, any single point in the XY plane, like that point there, which would be 4, 8, we can define that using an ordered pair, and we put this normally in the form of x, y. It's what we call, as I said, an ordered pair. And you know that when you see an ordered pair, that the first number tells you how far to go along the x-axis, the second number tells you how far to go along the y-axis in order to get to that point. And we call these things ordered pairs. But that's not the only way that we can define a single point on the xy plane. If we consider, for example, if this was a map and this is Rashawn's house out here. I don't know why I'm picking on you, Rashawn, but anyways. And Rashawn could tell me, okay, to get to my house, starting from here at Stanton, which is at the origin of the universe, he could tell me, I need you to go 4 blocks to the east, and I need you to go 8 blocks to the north. And that is the ordered pair 4, 8, like that. But that's not the only way to get to Rashawn's house, because if I happen to have a helicopter, the directions are going to be different that Rashawn's going to give me. He's not going to tell me to go 4 blocks. He's going to tell me, I would assume, he's going to tell me how many degrees to rotate so that I'm pointing in the direction of his house. And then he's going to tell me how far to travel in that direction to give me a straight shot to his house. That's what we call a polar coordinate. The 4, 8, it contains 2 pieces of information. How far east-west, how far north-south. Polar coordinates also have 2 pieces of information, but they're 2 different kinds of information. The first piece of information is how far do we have to rotate from the positive x-axis, some angle theta, so that we're pointing in the right direction. And then how far, we'll call it the letter r, how far do I have to travel in that direction to get out to the point? And we call that r, theta. That would be the polar coordinate that defines that point. Well, what I want you to do here, class, is I want you to figure out for 4, 8, what is the polar coordinate for that? If you know how to do right angle trigonometry, you can do that. You need to find out what this angle is right here, and you need to find the length of that hypotenuse. And I know you know how to do that. So I'll give you a few minutes to try to do that. So yeah, go ahead, try it. I'm going to find theta by using the tangent function, or actually the inverse tangent. That angle is going to be the inverse tangent of the opposite over adjacent. And then r is going to be, using Pythagorean theorem, is going to be the square root of 4 squared plus 8 squared. I'm going to bring my handy dandy calculator back into view. I'm going to take the inverse tangent let's see, let's turn it on. I'm going to take inverse tangent of 2, which is 8 divided by 4, if you didn't know. 63.4 degrees. Okay, so I now know my theta is 63.4 degrees. My r, I'll do this by hand, that's going to be 16 plus 64, which is equal to the square root of 80. What is that? 16 times 5? Would that be correct? I think it is. So that means that that would be 4 square root of 5. That means the polar coordinate would be square root 16, let's erase that. It would be 4 times the square root of 5, comma, 63.4 degrees. That is the polar coordinate equivalent to the rectangular coordinate of 4, 8, like that. Okay, so nothing too complicated about that. Let's try another one. And what I want you to do is find the polar coordinate for this point that I had put on this example. -4, 6. I'm going to erase this so we're not so cluttered. And I want you to find the polar coordinate for this. I'm going to draw the vector straight out to it. You need to find that angle, theta, and you need to find the length of the vector from the origin out to the point -4, 6. I'll give you some time to work on that. Maybe we will pause the video at this point. So go ahead and pause the video, Mr. and Mrs. Substitute. Thank you. All right, I assume you had a chance to work on this. Well, what did I do to come up with the answer here? I made myself a right triangle. I know that this length is 6, this length is 4. So what I did is I found this angle and subtracted it from 180. That's going to give me this angle right here. So for the rectangular point -4, 6, the theta is going to be 180 degrees minus the inverse tangent of 6/4. The length of the vector that goes from the origin out to the point -4, 6 is going to be the square root of 4 squared plus 6 squared, which is the square root of 16 plus 36, square root of 52, and if I know my radicals, that's 2 root 13. I do need to take the inverse tangent of 6/4, so there's my calculator. Second function, a tangent, 6 divided by 4 is 56.3 degrees. So that's 56.3 degrees, except I have to subtract that from 180. That was the whole point. Bye-bye. Calculator, come back. We'll take 180 minus that equals 123.7. Bye-bye. And oopsie-daisy, 123.7 degrees. And there's my polar coordinate, 2 root 13. That's the length of the vector, comma, 123.7 degrees. That is the polar coordinate equivalent to the rectangular coordinate -4, 6. All right, let's move down. The last thing that we'll cover here is this concept about there being an infinite number of polar coordinates for any single point. And that's because if I take a polar coordinate, I could always add to it a multiple of 2 pi or a multiple of 360 degrees and get a new angle that's going to really be the same point. What I mean by that is if I come back up here to this point here, if I add 360 degrees to this and make this 2√13, comma 483.7 degrees, that's the same point, because I rotate the 123.7 and then I rotate another 360 degrees, I'm still going to end up at the same point. I could add another 360 to this and get another polar coordinate. They all represent the same point on the XY plane. One of the things that we use to make our graphing of polar coordinates easier is we use this polar graph paper. It looks confusing maybe and it looks different, but never lose sight of the fact that this is still the x-axis. Students forget that and they think that this is like something from Mars. It's like totally different, but it's really not. It's still the XY coordinate system, but the thing that makes this different is instead of putting a grid, a square grid like we do for rectangular, we put these concentric circles. And so as I count out to these concentric circles, those are my R values. So for example, if I'm going to plot 4, pi over 4, the way that we graph these polar coordinates is, number one, do the rotation first. So you've got to get yourself pointed in the right direction before you go out that many units forward. So what we do is we come out here to pi over 4, which is 45 degrees, and I'm going to make a dashed line. And then I'm also going to make a dashed line back this way. So that's one straight line right here. And it's a positive 4, so I'm going to come out here and count 1, 2, 3, 4. That right there is the polar coordinate 4, pi over 4. I pointed myself in the 45-degree direction and counted out 4 concentric circles. Each one of those circles is 1 unit of measure. So that is 4, pi over 4. So you rotate first and then you count along the dashed line that you've drawn. And that puts you at the polar coordinate point. One thing that I do want to mention here is what it means when you have a negative R value. Suppose that I wanted to plot -4, pi over 4. Well, I'm going to rotate first, and so I'm going to come along this dashed line. All right, so I'm pointing, I'll use red here. So basically what I'm doing here is I'm pointing in this direction. Okay, and so since I'm pointing, that's positive 45 degrees. All of these are the positive R values. But back on the back side out here, these are the negative values. So I'm pointing in the pi over 4 direction, but -4 means count backwards on the back side of the arrow. And so this out here is -4, pi over 4. And that's how we plot polar coordinates. All right, so what we can see here is that these polar coordinates are 180 degrees apart from each other. The difference between -4 pi over 4 and 4 pi over 4 is that they are 180 degrees. Right, that's 180 degrees along that straight line apart from each other. And that's that. All right, so that's all that I wanted to cover today regarding polar coordinates. The assignment that you have for Thursday is Math Excel 6.4, and you need to do the first 5 problems. First 5 problems on that Math Excel. You probably have some time left in this period, and because this probably didn't even go an hour yet. What I recommend doing is the substitute can have you get out your laptops out of the cart and go ahead and start working on your Math Excel. Okay? And I will see you all Thursday. Okie doke. And don't give the substitute a hard time. Thank you. Work hard. Bye.